All right, good. All right, we're recording here. Please do turn off. I might hear one more microphone. Please do turn off your microphone. And it is appreciated if I can see your face, so I would appreciate turning on your videos. Um, okay, so today we're going to go over test number 2. So a couple things about test number 2. It will be on Blackboard. I have made a link on Blackboard. Let's see, it's called 210 exams. And that's where the test is going to be, 210 exams. You're going to have 60 minutes to take it. You can start at any time Friday between 8 a.m. and 11:59. Once you start, you're going to have 60 minutes to finish, with the exception of people that have accommodations who usually have a little bit longer to take the test. Speaking of accommodations, it's important because now the testing center is not helping us with those. If you have accommodations, I need you to email me today within an hour or two. So like basically by the time class ends or as soon as class ends, I need an email from you. I need to have your name and I need to know what exactly your accommodations are. And I just sent an email about this. Please make sure that in the subject line of that email, you say the word accommodations. That'll help me find the email quickly. So if you have accommodations, send me an email now or within an hour at least, telling me what your accommodations are so that I can take care of those. I'm trying to think. Does anyone have any questions or comments about the general structure of the test coming up Friday? Okay, well, if no one has, feel free if you have questions to kind of turn on your microphone and ask a question whenever. I have the test in front of me. I don't believe you can see it. Hopefully not. I'm gonna make sure you can before I start. I'm gonna do what I did last time. I'm basically gonna look at every single question on the test and give you a study guide for what things are most important for you to know about this test coming up. Okay, good. Yeah, you cannot see the test. Okay, so the first question I'm looking at here, the answer to this question is a convenience sample. And so it's basically describing a situation, a research scenario, and it gives you several different types of sampling. And you will have to read the scenario and then choose the correct answer, which here in this scenario is the correct answer is convenience sampling. So I'm not telling you what the scenario is, but I'm just telling you that you definitely need to know what convenience sampling is. Okay, next. By the way, once again, if you have questions, feel free to just ask them and whatever. I'm just going to go through. There's 38 questions. I'm basically going to go through all of them. So here's a question that's about, we use the normal, well, okay, let me, well, I just kind of said it, but this distribution right here, that's the normal distribution right there. And one of the things that we've been doing is using z-scores to calculate percentiles. Can anyone remember what is a percentile? I think I told you this last class. Does anyone remember what a percentile is? So for instance, if I'm drawing this distribution right here and my z-score is z equals 0. Does anyone know what the percentile for z equals 0 is?
50?
It is. It's 50%. It's 50%. And so knowing that answer, can anyone tell me what is the definition of percentile? What does that even mean? What is percentile?
Isn't it the area like left of
Yep.
the score?
Yep. So for what I'm showing you right here on the whiteboard, all this area to the left of z equals 0. Percentile is always the amount of area to the left of a given z-score. And so this question, it's about normal distributions. I'm not going to tell you exactly what the question is, but it's about normal distributions. And the good thing about normal distributions is that they allow us to calculate percentiles. Percentile is the amount of area to the left of a given z-score. Cool. Moving on. That was the second question here. In class, and I believe they talked about this in the textbook, it talks about one of the main weakness of convenience samples. So I'm not going to give this one away because I don't think this one's too hard. I'm pretty sure we talked about in lecture, and it's also talked about in your textbook. You probably even answered some homework questions about it via Launchpad. But it's the primary weakness of convenience samples is the main concept of the third question that I'm looking at right here, the primary weakness of convenience samples. Okay, moving on. Any questions so far? Okay. So here's a problem where it gives you the mean of a population, the standard deviation of a population, and it says that a person has, okay, so yeah, this question is basically, what is the difference between a negative z-score and a positive z-score? Conceptually, what do these things mean? If you have a negative z-score, how does that make you different compared to a person that has a positive z-score? Can anyone tell me that? What is the primary difference between a negative z-score or and a positive z-score? As far as, I can make this a little better, as far as where they're located on a distribution, what is the difference between a negative z-score and a positive z-score? I know people know this because people were answering this correctly last class. What is the
A
difference?
negative z-score is below the mean and a positive is above the mean.
Yep. So you'll definitely, there's several questions where you're going to have to understand that a negative z-score means below the mean and a positive z-score means above the mean, which means that for a given distribution, what z-score is the mean? What is the mean of, what is the z-score of a given distribution of what represents the mean of that distribution?
Z-score of 0.
A z-score of 0 is the mean of a distribution, and that makes it so that if you have a negative z-score, you're below the mean, below 0, and if you have a positive z-score, you're above the mean, above 0. Moving on. Right. Okay, so there's also a question where it gives you an example, and I think I told you about this way back in chapter 5, which feels like forever ago because we lectured about this in class. But there's a question where it gives you like a little scenario, a research scenario, and the answer to the research scenario is it's a volunteer sample. And I think I told you about this in chapter 5. I highlighted for chapter 5 in particular some of the terms that I knew were going to be on test 2, and volunteer sample is one of them. So you need to make sure that when you get to this question that you're going to be able to know what a volunteer sample is. And I gave an example in class, and there's an example given in the book, and it's just like the scenario that I'm reading here for this question. So if you understand the examples I gave in class and the ones in the book about a volunteer sample, you should be fine for this question. Yeah, this question seems pretty easy to me, at least. There is a question where you have to know what replication is. We talked about the fact that a lot of studies in the past have had false positives, and that when people tried to replicate those findings in the future, they were not able to. Could someone tell me, what does replicate mean? If I'm trying to replicate a finding, what does that mean?
Does it basically just mean you can redo the experiment or redo like the like you can retest it but with a separate sample? It doesn't necessarily hold up.
Yeah, well, if it fails to replicate. So replication usually implies that you are able to redo the study with a new sample and you get the same results as the original study did. That's replicating findings is when you get the same results as an original study with a new sample. You fail to replicate if you try and do the study again, but you are no longer able to get the same results as the original study. So there's replication and I fail to replicate. So I don't think that question is going to be too hard, but you do have to know that the answer is replicate findings. Okay. Okay, there's definitely a couple questions where you have to use the normal Z formula. So does anyone remember what was the original Z formula? I've given you two now. What was the first Z formula that I gave you? Anyone remember? I know people remember, so someone needs to say it. What is the Z formula?
X minus mu over standard deviation.
Yep, X minus mu over sigma, which is the standard deviation. So there's several problems where it gives you there's four things here in this formula. There's Z, there's X, there's mu, and there's sigma. There's several problems where the problem gives you three of those things, and you're gonna have to use algebra to solve for the fourth one. So let's see. So for this one, it gives you the X value, and it gives you the mean of the class, the mean of the population, and it gives you the standard deviation. And you have to calculate how many standard deviations is Adam's score from the mean. And that is the Z-score. Remember, what the Z-score represents is how many standard deviations from the mean are you? How many standard deviations is a given X value from the mean? So for this one, it gives you the X value, the mu, and the sigma, and you need to calculate Z. That is, you need to find out how many standard deviations that X value is away from the mean of the population. Any questions, comments so far about anything going on? Okay, here I'll just literally read you the question. Random assignment overcomes many of the limitations of. So I'm not going to tell you what the answer choices are, but random assignment overcomes many of the limitations of. Then you're going to have to choose random assignment, the thing that it helps overcome the limitations of. Okay, moving on. Right. Okay, so here's back in chapter 5, we talked about the difference between random assignment and random selection. And I'll allow you to look up, there's some pretty good figures in the chapter 5 slides that I think are helpful for this. I will just say right now that random selection is I don't actually know of any psychology studies that I've ever read that actually use random selection. Because what random selection is when you have, if you're interested in the difference between men and women, random selection is when you take all of the men and women in the world and you randomly select from all of those men and women in the world to be in your studies, which means if I'm doing a study on men and women, then I would randomly be selecting people from Russia and randomly be selecting people from China and India and stuff like that. But that never actually happens. Because it's just too difficult, because the world is too big and it's just way too difficult to do studies like that. That's random selection. And so you need to know what that is and how it's different than random assignment. You need to know how random assignment we often use in every study I've ever done. As a psychologist, I've used random assignment, but I have never used random selection. So you need to know the difference between those two things. Moving on. Oops. Okay. Here's another, looks like this is another one where you're going to have to use the Z formula. Uh, so it gives you the mean. So it says the average of the population, the mean of the population, and it gives you the standard deviation. And it also gives you the X value. So this is kind of similar to the other one. You're going to use the Z formula once again. It says, what would the Z score be for a person whose self-esteem was blank, was blah, blah, blah. And so once again, for this problem, it looks like it's giving you the X value, the mu, and then the sigma, and you're going to have to solve for Z. So it looks like there's two problems where you're going to have to do that. Let's see how we're doing on time here. Oh yeah, we're doing okay. Here's a problem where it says, which of the following is an example of random assignment? And so you have, in this problem, several choices, and you have to choose which one is random assignment. Here's another problem where you have to use the Z formula. Okay, so this one's different though. So for this problem, the problem gives you the population mean, and it gives you the population standard deviation. So it gives you mu and sigma. It also gives you a person's Z score. The thing you're having to solve for, well, you tell me, if it gives you mu, sigma, and Z, what is the thing that you're going to be solving for in that problem?
X.
X is correct. If it gives you mu, sigma, and Z, then you'll be solving for X, which is what's going on in this problem. All right. Here's another question about random assignment. And you need to know, like, we talked about there's a question earlier as we talked about random assignment is used to overcome some of the weaknesses of blank. And I didn't tell you what that blank is. But another thing that you need to know is how exactly does it overcome those weaknesses? So random assignment helps you overcome weaknesses in something. I haven't told you what that something is, but I want you to know what that something is and how it does it. And I believe both of those things were mentioned in chapter 5. Okay, moving on here. Here's another one where it gives you the mean of a population. So it's another Z-score formula problem. So this is the fourth one now that we've had, Z-score calculations, where it says the mean, it gives you the population mean and the standard deviation. So it gives you mu and sigma. And it also gives you the Z-score. And once again, you're going to have to solve for X. So this is the second problem where you have to use the Z formula to solve for X. Okay, moving on. Here's an example. You have to know what illusory correlation is. I gave some examples. The book gave some examples. You probably had some online questions about illusory correlations, but I'm not going to tell you the question here, but the answer to this question is illusory correlation. Okay, so way back in, I think this was one of the, maybe it was the week before spring break, so it was kind of a while ago now. We did the problem with the 3 Smith brothers. There was the guy in 1st grade, the Smith brother in 5th grade, and the Smith brother in 9th grade. And this is a problem where it uses Z-scores to answer the question of which Smith brother is tallest for his age. That is, which Smith brother is tallest relative to his class. And there's several problems on the test, and I'm looking at one right now where you have to basically do that same thing. So basically, in those types of problems, you'll always be comparing a student in like one class or in one population to a student in a different class or a different population. And you'll be calculating the z-score for each student, and then determining like which student had the higher z-score or which student had a z-score that is farther from the mean of the distribution. Someone tell me again, by the way, a z-score of what represents the mean of a distribution?
0.
0, thank you. Let me just look at the answer for this one. Yep. So my suggestion for how to study for these types of problems is we did a great example in class with the Smith brothers. Go back to that example that's in the chapter 6 slides. Make sure you can do it by yourself. For us, we had to calculate, I think, 3 z-scores. For the problem I'm looking at, it looks like you only have to calculate 2 z-scores. So if you can do the Smith brother problem, you should be able to do this one. This one looks even, the maths on this one, I believe, is even easier than the Smith brother problem. So this problem is easier than the one we did in class by a little bit, just a little bit. You also need to know what a personal probability is. This is another term from chapter 5. Personal probability. I don't think you guys have much trouble with this. I'm pretty sure that we talked about like probabilities, like somewhat. So you guys remember there's 52 cards in a deck of cards. If I randomly draw out, what is the probability if I reached into a deck of cards that I would randomly draw out the ace of spades? Does anyone know? What is the probability that I would, if I randomly drew a card from a deck, what would be the probability that I would pick the ace of spades?
1 in 52.
Yep. So there's problems like that with deck of cards and probabilities. Knowing that there's 52 cards in a deck, what is the probability of? Oh, and it's also important to know, like, you guys do know, like, how many aces are there in a deck of cards?
4.
Yeah, there's 4. Okay. Okay, so here is a problem which, yeah, I actually want to open some slides for this problem because we've talked a little bit about this idea, but I just want to make sure. So I'm going to minimize the test so you can't see it. And then I'm actually going to show you my desktop again. All right, let's see. So this is chapter 6. You guys can see my desktop? You can see my slides? Okay. Yeah, there's the Smith problem right there. So do that problem. That was the one I talked about just a second ago. Percentiles. Here we go. Okay, so first off, we're looking at the normal curve right here. What are these numbers at the bottom? -2, -1, 0, 1, and 2. What are those numbers down there?
Z-scores.
Those are z-scores, thank you. And let's just do a couple of practice ones. First off, what is the percentile of 0? That is how much area is to the left of 0?
50.
Yep, it is 50%. If you took the area of this over 50%. How much area is between a z-score of 0 and a z-score of 1? What percentage out of 100 is between a z-score of 0 and 1?
34.13.
Excellent, 34.13. So the problem that I'm looking at right now in the test, or that I was just looking at right now in the test, it asks you how much area is between a z-score of -1 and +1. Can someone tell me if the amount of area between z and 1 is 34.13%, how much area would be between a z-score of -1 and +1?
Wouldn't it just be double that?
Exactly, which would be 68%. And my understanding is that, yeah, you're not going to have, I mean, you technically, it's impossible for you to, you can use the slides now. You only have 60 minutes to do it, to take the test. So you're not going to want to be looking everything up when you do it. So you might actually could have this thing in front of you when you want to. But my suggestion is just to memorize that. It'll be faster if you just memorize it. I'm going to go back to the test now. The percentage of area between a z-score of -1 and +1 is about 68%. So now I'm going to go back to the whiteboard here. All right, bring back up the test. Okay. Oh, and I'm going to remind for the question still about, it says in a standard normal curve, approximately blank percent of scores fall within 1 standard deviation of the mean. And I want to make sure that you don't get confused about the wording of this question. It says falls within 1 standard deviation of the mean. That means 1 standard deviation on the positive side of the mean and 1 standard deviation on a negative side of the mean, which is basically another way of saying is how much area is there between a z-score of -1 and +1. But the specific wording is what percentage of the curve falls between approximately blank percent of scores fall within 1 standard deviation of the mean. So that's on the positive side and the negative side. What is the for that? So just don't forget that. The answer is what we just said. Okay, yeah, I just want to go to another thing from the slides. This one will be from chapter 5. So minimize this. Oh, yeah. Yeah. So this thing right here, we talked about this in class, and it was kind of didn't really fit with any of the other stuff we were talking about. So I just called it an important fact about probability, but you need to know this fact. And it had to do with rolling dice. Rolling 2, then 3, then 6, then 4. The probability of doing that is the exact same of rolling 2, then 2, then 2, then 2. If you rolled 4 2s in a row, it would feel like very special, or it'd feel like, oh my gosh, how could that happen? Rolling 4 2s in a row seems so unlikely. But technically, mathematically, the probability of rolling 4 2s in a row is exactly the same as rolling a 2, then a 3, then a 6, then a 4. And there's a problem where you have to know that fact. Okay, let's go back to the whiteboard here. All right. Okay, so there's also a question where you have to know the percentile for a z-score of -1. So someone tell me again, what does percentile mean?
It's the area to the left of a z-score.
It is the amount of area to the left. So you're going to have to know the amount of area to the left of a z-score of -1. A z-score of -1, how much area is to the left of that? So that's that problem. I'm telling you the exact problem, basically. In a standard normal curve, what percentile corresponds to a z-score of -1? That's literally the question. There's a problem where it asks you to choose something which represents independent events. We've talked about statistical independence. I believe that was in chapter 5 is probably where we introduced that. I'm not actually 100% for sure about that, but we definitely talked about independent events. Yeah, I believe it was chapter 5. And you're going to have to choose the event which is independent out of some, multiple choice. Almost done here. I think we got like 10 more of these left. There is a question about the central limit theorem. And this is like a fill in the blanks, basically, where basically this problem, there's 2 blanks, and it's basically you have to fill in 2 of the missing words from the central limit theorem. So my suggestion is to actually kind of just memorize the central limit theorem. You need to know what a null hypothesis is, which I do not think most students have problems understanding what a null hypothesis is, but you're going to need to know what that is. And there's problems where it gives you like a research scenario and then lists different outcomes, and you have to choose which one is the null hypothesis. You have to know the difference between a distribution of means and a distribution of raw scores. You have to know the difference between a distribution of means and a distribution of raw scores. And this is the stuff towards the end of chapter 6. The distribution, the central limit theorem, by the way, is something which concerns distribution of means, not distributions of raw scores. The central limit theorem is more about the distribution of means and not about distributions of raw scores. That one's easy. That one's kind of easy. But this is another one which requires you to know the difference between a distribution of scores and a distribution of means. Let me ask it this way: in which type of distribution, a distribution of means or a distribution of scores, is the sample size bigger than 1?
Distribution of means.
Yes, thank you. A distribution of means, the sample size is bigger than 1. Just charging here. There we go. Okay. Okay, so here's a question where you have to know what the alternative hypothesis is. Looks like we got 6 more to go. Yep, there's several questions about whether you accept the null hypothesis or you reject the null hypothesis. That confusing language about failing to reject, that is listed in the test, but every time it says fail to reject, I'll put in parentheses accept. So that makes it a little easier for you, I think. But there are some problems where you have to know, in this research scenario, did someone accept the null hypothesis or did they reject the null hypothesis? Yep, there's another one. Yeah, okay. Oh, I'm just going to tell you this. This is one about the distribution of sample means in the central limit theorem. In the central limit theorem, it basically says, and I talked about this in last class, but I want to remind you because there's a question like this. The bigger the sample size gets, So we remember, okay, well, someone tell me real quick. When we did our distribution of means activity before spring break, and then we talked about it last class, what was our sample size? You calculated, when we did those, the coins where you reached into the bags and pulled out the different coins, and each coin represented either $1, $2, $3, $4 donation. You calculated sample means, and each of those sample means had a sample size of what? Can you remember? No one remembers. It was 5. It was, the sample size was 5. You reached into the bag 5 times. You wrote down each of those 5 numbers, and then you took the mean of those 5 numbers, and you repeated that 10 times. And so those you were calculating. We made a distribution of sample means among my 2 classes with 250 sample means. Each of those sample means used a sample size of 5. That is a mean calculated using 5 scores. And a mathematical rule based on the central limit theorem is the bigger the sample size. So our sample size was 5. And when we did that, we got, I actually want to show you this. Where's chapter 6? Let's see. So here is our population. Oh, wait, you can't see it yet. Let me share. Okay, now you can see it, I think. This is our population distribution. And this is our, I'll minimize this. Come on now. And this is the distribution of sample means. Looking at these 2 histograms, can you guys tell me, and you can also look at the numbers if you wanted to, which of these 2 distributions, the population distribution or our distribution of sample means, which of these 2 has smaller variability? Which one has a smaller standard deviation?
The first one.
This one actually has a bigger standard deviation, and it's because this number right here is 1.18, and you can see that the population histogram is wide, whereas this one has a standard deviation of, for us, it was 0.47. And so this distribution of sample means has a smaller standard deviation than the original population from where it came. And this is something that happens because of this part of the central limit theorem right here. The bigger your sample size, the smaller the standard deviation of your distribution of sample means will be. I'll say that one more time because it's pretty darn important. The bigger your sample size, for our activity, our sample size was 5. The bigger the sample size, the smaller the standard deviation of your distribution of sample means will be. So if we had used a sample size of 10, and then we made a distribution of sample means, would it have been thinner or fatter than the one that we made right here? If we would have used a sample size of 10 instead of 5, how would it have changed the thickness of the distribution of sample means that we would have made? Would it have made it thinner or fatter?
Thinner.
It would have made it thinner. Thinner means less variability. It means less standard deviation. The bigger the sample size, the thinner the distribution of sample means becomes. Okay. Okay, so there are a couple problems here. It looks like 1 or 2 where you actually have to use the standard error. Remember the standard error, which is something which is defined in the central limit theorem. Does anyone remember what is the, what is the I don't even know how to ask this question. So I'll just say, this is the standard error. Right there. And so this problem, I guess I can just say it. It says, if a distribution of scores has a mean of 42,000 and a standard deviation of 1,755, The standard error of the distribution of means based on sample size of 120 is. So that's the problem. Let's see, the distribution of scores has, so that's the population mean is 42,000. The standard deviation of the population is 1,755. And you know that the sample size is 120. And it asks you to calculate the standard error. So I'm not gonna actually show you the exact math, but basically you're gonna take the standard deviation divided by the square root of n, divided by the square root of the sample size. That's how you.
Would 120 be n in that
Yes.
case? Okay.
Yes, it is. Okay, moving on. Okay, so this question's here. I'm not a huge fan of this type of question, but I'm giving you a heads up to make it as easy as possible for you. You basically need to know that you need to memorize type 1 and type 2 error. I'll just say this right now. A type 1 error is false positive. Type 2 error is false negative. But you're going to need to know that for the test. You're going to need to know which one or 2 is false positive and which one is false negative. Type 1 error is false positive. Type 2 error is false negative. You're going to need to know that for the test. And then this last problem, I actually am going to do it for you. Well, kind of. I'm going to do the math for you. You're still going to have to do the conceptual aspect of it. So I'll read this to you now, the question. This one seems challenging. This is the last question. Imagine the average university has 8.5 students hospitalized for mental illness each year with a standard deviation of 3.8. A systematic study of 23 counseling programs at universities resulted in a mean hospitalization rate of 9.3 students. Another study involving 19 programs resulted in 6.9 hospitalizations. Which result is more unusual? So this one is a challenging problem. So I'm actually going to do the math for us here, and then you'll just have to kind of make sure that you understand conceptually what we did. Or here, you'll have to make sure you understand it conceptually on the test. So there's a lot going on in this problem. And basically this problem requires us to calculate 2 z-scores. But the z-scores now require us to use, the z-scores that we're going to calculate for this problem require us to use this formula. X minus mu divided by this. So for the formula that we're going to be using, usually it's just standard deviation in the bottom. For this problem, though, you have to have standard error in the denominator when you're calculating z here. So that's what we're going to do. But for this problem, you need to calculate 2 z-scores. So I'm going to erase this so I have more room. The mu for us for this problem is 8.5. That's the average. The average university has 8.5 students hospitalized. So that's the population mean. The average university hospitalizes 8.5 students for mental illness each year. And the standard deviation is 3.8. So that's like the population information. And so then it says, a systematic study of 23 counseling programs at universities resulted in a mean hospitalization rate of 9.3 students. So this is a single study, and the sample size of this study was 23. N for this study that we're talking about is 23. A systematic study of 23 counseling programs at universities resulted in a mean hospitalization rate of 9.3. And so the way you would set this problem up is that mean, that sample mean, it becomes the X in our z-score formula. So it would be like this. Z equals 9.3 I don't know why that happened. Z equals 9.3 minus 8.5. What is that 8.5 again? Do you guys remember what is that 8.5?
Population mean.
That is the population mean. And this 9.3 that we're talking about here, this is the sample mean from a study where we only took 23 universities. So in the country, there's hundreds or thousands of universities. A single study just looked at 23 of them, and it calculated the mean hospitalization of these 23 universities. And it found that the mean hospitalization of those 23 universities, that sample, was 9.3. The population mean was 8.5. And then we have to, the denominator is using the standard error. So the standard error here would be the population standard deviation, which is 3.8, divided by the square root of our sample size. Does anyone remember what I said the sample size was?
23.
23. So that's, you have to calculate the z-score for that study. And I'm not going to tell you exactly what that is. I think the math is pretty easy. But there's also another, you have to do it for a different study. And the other study, it says another study involving 19 programs resulted in 6.9 hospitalizations. So you would do the exact same thing. I guess I can do this for you, except for the second, so the second one, it says another study involved 19 programs. So the sample size for 19 programs because is now 19 down here. So N becomes 19. But it said for this other study, another study involving 19 programs resulted in 6.9 hospitalizations. And then you have to calculate the z-score. And then it says which result is more unusual. The way you do that is by calculating both of the z-scores, the z-score for study number 1 and the z-score for study number 2. And the way you determine which one is more unusual is which z-score is further from the mean. And by the way, the z-score of what represents the mean?
0.
0. So you're going to calculate these two z-scores, and don't forget the denominator of these z-scores, you're using the standard error, because we have sample sizes of 23 and 19 for this problem. Whichever of those two z-scores is further away from 0, that is the result, which is more unusual. Okay, so we're a little bit past time here. I actually am going to do the study session again for my other class, so you can hang around if you want. I'm also very willing to have Zoom office hours after these studies. My other study session will end at 11 a.m. And if anyone wants to ask follow-up questions regarding the test, we can do that. Just send me an email and we can make an appointment to meet sometime today, or I guess we could meet tomorrow as well if you have further questions about stuff. But I need to get going because I need to prepare for my next class. And I need to stop this recording. Okay, so I will see you guys later.